Hello everyone, I'm HK and in this tutorial I'm going to talk about binary number system. First, I'll give you a little introduction about binary number system. So after that, I will show how to convert a decimal number to binary number. Decimal to binary. Then I'll talk about binary arithmetics, which means binary addition, subtraction, multiplication and division. For this video, I'll do these two parts: introduction and decimal to binary conversion. So let's begin. As we all know, computers are using binary number system to store data. For example, computers saving data in their main memory, mainly in RAM. If we take a RAM card, I'm pretty sure you all have seen this device has blocks like this. Some blocks. Some RAM cards have only one series of blocks, some have two. Likewise, there are blocks. These are the IC devices which are saving data inside it. If we take one of these ICs and zoom it, there are so many electrical devices: resistors, capacitors, transformers. Likewise, computers use the 1 and 0 to save data. To understand, I'll explain it like this. Let's say one of these blocks have series of capacitors like this: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Assume there are so many capacitors. Actually, there are millions and billions of capacitors in one of these blocks. I have only around 12 of them. Just assume we have to represent binary number 1, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1. So how we can represent these three numbers in this memory block? Computers understand this thing like this. If there are electrons in these capacitors, simply, if this capacitor is fully charged, computer will take it as a 1. If one of these capacitors are not charged, computer will take it as a 0. So if we want to represent this number, we have to charge this capacitor and charge this one, neglect this, and charge this one. So that's how we can do it, and that's how the computer does it on its RAM. Let's assume this number. For this number, we have to pass this capacitor and charge all other three. Likewise, in the last case, we have to charge all of these capacitors. That's how computers store data. Actually, there are different methods. This is only one method, and this is only for this example, and the real methods are different from these methods. However, this is the basic method that computers store data. So this is why we are going to need a better understanding of binary number system. So first let's look how we can convert a decimal number to a binary number. There are two methods. I'm going to first tell you the easiest method. Let's assume we have to convert binary 107 into the decimal number 107 to binary. What we have to do is just divide it by 2 while mentioning the remainder. If I do this will be 5, then this will be 3, and there will be 1 remain. If I divide this 53 by 2, this will be 2, and this will be 6, and 1 remain. Likewise, I can divide, this will be 13 and no remainder. This will be 6 and 1, this will be 2, so it will be 3 and 0. Again, this will be 1 and 1. Now we have got 1, so we can stop this process. And now we have to do is we have to write this number in this order. So it will be 1 1 0 1 1 1 0 1 0 1 1. So this is how we can represent decimal 107 in binary format. Now let's make sure is this correct. To do that, we have to write it like this. And represent these place values. This number is in binary format, which means the base is 2. So this will be the place of 2 into power 0. This will be 2 into power 1. This is 2 into power 2, 2 into power 3, 2 into power 4, 5, and 2 into power 6. Now what we have to do is calculate these values and add them together. 2 into power 6 is 64. 64 plus this is 32, plus here it is 0, plus 2 into power 3 is 8, and this will be 0, 2, and 2 into power 0. Actually anything into power 0 other than 0, it will be 1, so this will be 1. After we calculate this value, 64 plus 32 is 98, plus 11, 8 plus 1, sorry I have done this wrong, this is 96. So answer we will get is 107 again. So this is how to convert a decimal number to a binary number, and as I mentioned earlier, there is another method. Now I am going to describe that method. Before we do this method, you have to remember the powers of 2, which are 1, 2, 4, 8, 16, 32, 64, like that. at least you have to remember 2 into power 10. So now let's say we have to represent decimal 211 in binary. What we do is write this. This will be 64, 128 and 256. This is enough to convert this 211 into binary format. As we can see, 211 is less than 256, so we can't get 256. And what we can do is add some other values to 128. Let's first get 128, and we have to add another. I will subtract this 128 from this. (211) minus 128, that will be 3, 8, so 83. We have another 83 remaining. We have to create this 83 using these values. So I will get another 64, and we have remaining 83 minus 64, which will be 9 and 1, 19. So again, to get 19, we can't get 32 because it is more than 19. So in here we place a 0 to skip 32 and plus 16. Why we add 16? That's because 19 is less than 16, so we can add 16 and plus. Now we have to again minus the 16 from 19. This will be 3, and to represent that 3 we cannot get 16, we can't get 8, or we can't get 4. So we have already written 16, so we don't put another 0 to it. We get 8 and 4, and now as we can see, 2 plus 1 is 3. So we get 2 and 1. Now what we have to do is, if there is a number which is not 0, we have to put 1 in there. In this case it is 1, 1. When there is 0, we keep it as it is. 0, 1, 0, 0, 1, 1. So the final answer is 1, 1, 0, 1, 0, 0, 1, 1. This is how we can represent 211 in binary. This is actually, you might feel this pretty hard, but once you get used to this method, this is easier than the other method. All you have to do is just get familiar with this. So let's take with the calculator. Put 211 here, and as you can see, it is in binary 1101 0011. So this is how we can convert a decimal number to binary number. I will see you in next video.